Sir, I have a doubt.
Yes, you can ask. Yes, please ask your doubt. Hello.
Yes, so actually, yesterday, while I was creating the map, I was getting some error
Okay. In which part?
in the K factor.
Okay. So means okay. Can you share your screen and
I'm
show
not,
me?
yes, yes, sir. So,
The
this one is,
upside down part is corrected.
yes, yes. And this one, while I convert this to um,
Okay. Select the field option. Please select the field which you want to do. Field to use for burn in value. Yeah, for K factor. Yes. Now I can.
yes. Sir, here it is invalid value for parameter output raster size units. Why is it showing this?
Hmm. Okay. So okay. Yours there you say that 30 meter na, the 30 resolution.
Yes, yes, yes.
Okay, just change it to 0 point something.
0.1.
Yeah, 0.01. Let's say, put 0.01.
0.01. Okay. Should I run, should I run this?
Yeah, run it. Don't save it. Uh,
Oh,
if that is run correctly, then you can save.
it is showing that wrong or missing parameter for the output raster. Output extent.
Which one? Okay, just output raster size unit. Output raster size unit.
This one, pixels. Okay.
Yes, yes. Yeah.
Error.
Okay. Click that the pixel and then just means correct that with 30 meter resolution.
Okay.
Actually, what is the thing that if we first we have to change that projection, then if you put the 30 meter, I think
Sir, I
it will
tried
work.
that one also, but it was not working.
Okay, okay, okay. Everything is same. Then go to this run the file.
I'll save it. This is not showing up.
No,
Like
this is wrong. This is wrong.
if I
It's
reproject
not.
it.
No, no. Now it is nothing to reproject. Okay. So first reproject that soil clip, then try to process it. Reproject using that UTM 45 north. Okay.
Okay, 46 north.
Okay. Yes. 46 north.
And then after this,
No,
uh,
not here. Not here. You have to search for reproject.
okay.
Then you have to do that reprojection. Yeah. Reproject layer. That one. Target CRS 45 46 north. Yes. Just run it. Don't save it. That just run it.
Then,
Okay. Then go to that raster to polygonize. Yeah. Reprojected. No, input layer is reprojected one.
okay, okay, sorry.
Yes. Then the K factor.
7
Then
pixels,
output raster size unit pixel.
50 pixel, 3
Okay. Just click run. Okay. No. This is still incorrect. Okay. In my system it is correctly generated. Na? Okay. Okay. Can we have a meeting in at let's say in Saturday or Sunday, so I can see what is the wrong actually.
Okay,
Okay.
yes.
Okay. So okay. So let's start. Let's start today's class. So basically, yesterday we created three factors. Okay, that R factor, K factor, and LS factor. Okay. So Abhijit, you tried that K factor.
No, sir. I will try tomorrow.
Okay. Okay. No worry. Okay. So I'll ask that if you having same you're facing the same issue as Madhuwala.
Yes, sir. I will try tomorrow and let you know, sir.
Okay, okay, okay. So okay, for today we will using DEM data, and we are creating the LS factor. Okay. So LS for LS factor we have the formula. Okay, this is the formula for LS factor. Basically, there are various formulas, and okay, this is the latest one. Okay, so this is to calculate L factor, and L factor basically slope length factor, and slope length is basically calculate using that flow accumulation. Okay, and this is the slope steepness or the S factor, and you have to multiply the L factor and S factor. Okay, so so to calculate the slope and all, we need the DEM data. So here are some sources to download the DEM data. Okay, so here we have SRTM. So SRTM basically you can find SRTM of 90-meter resolution and also for 30-meter resolution. Okay, so basically this is collected in 2000s. So basically they it is collected by sending the aircraft. Okay, and the aircraft is generated this SRTM DEM. Okay, but also there are some others like Aster DEM. This is basically Aster. This is created using that Aster SAR satellite. Okay, so this one is a satellite DEM data. This one is a aircraft carrier DEM data. Okay. Then also we have also this Alos pulsar by Japan, and this is the highest resolution. See, 12.5-meter resolution. Okay. Then we have others like Tandem, but this is 90 per meter, not required for us. Also, we have Indian satellite known as Catosat. Okay, and you can find Catosat DEM of 10-meter resolution, but this is not freely available. 30-meter resolution is freely available. Okay, for to access the 10-meter resolution, you have to uh, means request them and to need to purchase it. Okay, but this Alos pulsar you can have the highest resolution, that is 12.5-meter resolution. Okay, so these are all the data set. So let us download some data. Okay, so to download SRTM data you have to go to the Earth Explorer. Okay, yesterday we already go to the Earth Explorer and downloaded the Landsat data. Okay, see we have this is the USGS Earth Explorer, and first we have to, so this is Dibrugarh, so we just have to create a boundary. Okay, okay, then go to this cloud cover and okay, this is also not required to download basically the DEM. You just go to the results. Okay, we have not selected the okay, so then go to the data set. Okay, in the data set basically you have all the data, and here you have this digital elevation data. Okay, so here you can find the SRTM, and SRTM has the 1 arc second non-void void data. Okay, so basically this is void field, and this is the raw data, and these data are basically 3 arc second data, that means 90-meter resolution data. Okay, so this is the SRTM 1 arc second, and this one is the basically 30-meter resolution data. Okay, just click on that and go to results. So here you can find only two data. So basically this is published in 2014, but the data is collected in 2000 itself. Okay, but between 1999 to 2000 they are collected the data sets. Okay, also you can see the data. Yeah, so we have two data set, and obviously these are fabricated data. This is not a good data. Okay, so you have the okay, but if you choose for 90-meter resolution, you can also download some data set for that. Okay, so here you can find that these are not basically, these are the data set are not available. Okay, so if you choose this data, we are not going to able to work on that. But for your area, you may find some data set. Okay, some good data set using this SRTM data. Okay, also you can directly download. Okay, this is also a very easy way to download. We can download in QGIS itself. Okay, let us first Dibrugarh save file. Okay, so this is the Dibrugarh save file. So for this extent, if you go to this plugin and search for SRTM downloader. Okay, see here you have the SRTM downloader. Okay, you just to install the plugin SRTM downloader. Okay, then yeah, just open it. See, when you opening it, you can set your canvas extent. Okay, this data also you can put in your SRTM when you try to download this one. Also, you can directly just create your path, select your path. Okay, like for me, this ls factor, the select this one. Then you can have this SRTM global 90 meter data, SRTM global 30 meter data. Okay, just click on that. Okay, and you need a API key to download. Basically, before that you basically needed some let's say login and password to download, but for now they are asking for API key. Okay, so here yeah. Okay, we have to go to the API section, and here you can find some API key for that SRTM downloader, and you can put that API key in here. Okay, so you can directly download for your region of interest directly for your for the SRTM downloader. Okay, but you already see that the SRTM is not a good data for our data set. Okay, for our region area. Basically, you there are various means errors when they calculate the this SRTM dem. Okay, so maybe for your area cartodem is actually good for your area, or for another area it might be SRTM might work. Okay, so basically you have to just try that which dem is actually uh, 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 means good for your area. Okay. Okay, see, for now, this is the 90 meter resolution data. Okay, 3 arc second. And you can see there are various patches here. Okay, see, these are basically patches here. Okay, so for, or we can try SRTM, then also we can try the Amsterdam. Okay, so for Amsterdam, you have to go to the Earth data. Okay, search for this NASA Earth data. Okay, here also you can find the link. Okay, here you can find all the links to download. Okay, so you can directly copy and paste, and you can download. Okay. Okay, so go to earth data. let me try to log in this one. I have not logged in. Yes. So this is the browser for to download. This is a browser for the Earth data. Okay. So first we need our region of interest. Okay. So basically this is the Dibrugarh. Okay. So we see that this is the boundary. Okay. So yeah. Okay. So we have our region. Now just search for Aster. Okay. So here you have the Aster data, and in the Aster data itself you have various data set. Okay, like the L1T terrain corrected data, Aster global digital elevation model. Okay, so this is the Aster digital elevation model. Okay, and this is from 2002 present data. Okay, just click on that. Okay, now we have various data set. Okay, so see, for our area basically, uh, one data, two data, three data, and four data. Okay, so we require to download this one, two, three. Okay, one, two, three, and four, and five. Okay, we need to download all these data set. Okay, so
Sir,
yes.
sir, can we not download the data from Google Earth Engine and then do
Yes, we
the
can
process?
download also, but I'm first I am explaining the traditional one that we have to download, and then
Okay,
mosaic
okay,
and clip, and
okay,
then also we can download from that
okay.
Google Earth Engine. Okay, so let us select only for 2025. Let's say 2025 January. Okay, to 2025. Yeah, actually the March. Yeah, we have to download this five tiles. Okay. So you have to download these five tiles. I think five tile is, oh no, one, two. Okay, no, this area is being missing. Yeah. Now we have all the data set. Okay. I think if we choose the April one, yeah, okay. For April, we only have the one and two. Okay. So let us try to download this one and two data. Okay. Just click on that, and you can find the image here. Okay. If you zoom in, you can find the image here itself. Okay, the dem file. Okay, so which one? this one, let us download that one. Okay. Okay, there are only one 11 MB and 12 MB file, these datasets, so these are not just that much bulk data. So yeah, so let us download for okay, for the these two. Okay, so this one also, the this one. Okay, I think if we download this 4 tile, so we can have all the um, for our study region. Okay, let's see. But also let me show you where to download our this cartosat dm. Okay, this is Indian dm data, so you can find in the bhunidhi portal. Okay, here you have the bhunidhi. Just search for bhunidhi, and you can find the also you can find the nicer data here. Okay, so then you have to go to the bhunidhi browser. Okay, see. Okay, so data finer than 5 meter is open for government entities and price for non-government entities. Okay, so we have 5 meter data also. Also, they have 1 meter data also. Okay, but this is not open for public. Okay, now you have to select your study area. Okay, so here you can select using the polygon. Just draw a polygon. Okay, and select your in the satellite you have this cartosat. Okay, select this cartosat one. Okay, and okay, open data. Okay, cartosat. So now if you submit, so see you have, see you have 4 data. Okay, and if you click in that, you can see, but here you also have problem. Okay, see, for the carto dam there are various error in this dam data. Okay, so for our region we see that the only data available is that the aster. See, this one is good enough. Okay, so one tile is actually good enough, but this all are basically, these are all this one also good data. Okay, so before download please check all the images when you are downloading an image. Okay, so
बोला सर हाँ तो फोन करना पाठक जी को उन्होंने कहा था 8 बजे करना तो मैंने अच्छा
yeah, okay, so
Sir, what is the reason behind this data issue? Why it is happening?
sensor problem only, because directly the DEM data is not collected. Now we have to first SAR data, they collected the SAR data, and then there is you have to process that data to generate the DEM file. Okay, and you need two basically data set for a same region. Okay, and a perfectly timing so that you can incorporate into insert, you can produce insert data, then you can produce the DEM data. Okay,
Okay.
and for the processing also there are sensor errors, various errors are there.
So, sir, this type of data issue is very common for the dumb data, right?
Yes, yes, yes.
Okay.
Okay, but this one is a good data. See, this is the good data only. Okay, you can. This is in N2592. Okay, those they are this one. You can find this one the good data. Okay, but uh, I like the most that allos pulsar dem. Okay, so this allos pulsar dem I like the most because it is giving 12.5 resolution. So obviously this is a bulky. If your area is larger, let's say for UK, if you're doing for Assam or state level, so this file is very heavy, allos pulsar dem. But for district level or any smaller area, you can use this 12.5 meter resolution data. Okay, so you have to go to this Alaska website. Okay, here also they have, no? Let me search for that. Yeah, here also you have the allos pulsar data. Okay, if you select here, uh, okay, or also you have to go to the Japan space. Okay, see, this is your Alaska dataset. Okay, so just select your area, Dibrugarh. Yeah, see. Okay, now you have to select the allos pulsar. Okay, so this one is the allos pulsar. If you select this one, yeah, now you have the data and you can see how. Okay, see, you can find very smoother data and all the data set allos pulsar. I never get any uh, incorrect one in this in this allos pulsar. Okay, so here you can find the 12.5 meter resolution data. Okay, okay, so you can download here also. Okay, let us import our Amsterdam dataset. Let's see that if the data is good enough or not. Okay, okay. So you can see that all the dataset are basically have okay. These are basically all the cloudy dataset. Okay, this is not a good data. Basically, these all are cloudy dataset. Okay, these are all cloudy dataset. See how much cloud is there. Okay, let us check that one. Amsterdam and okay, here also you can you will find that all the. Okay, for this region only I already pre-download all the data and process it like yesterday. We have we have been seeing the all the data set very quickly we are process it. Okay, okay, okay. Please let me download that one. Okay, okay. So this is our dem data. Okay, so we don't need this all the layers. Remove layer. Okay, yeah. Now, okay. So you can find that there is basically here you have this is basically your higher elevation area, and these are all the lower elevation areas. Okay, so we have our DEM data for SRTM data. Okay, just when you download from uh, this Google Earth engine. Okay, so here I think, yeah, I did not specify here to clip the data. Okay, that's why it giving this area also. Okay, so remember to write here the dot clip ROI. Okay, so that it clip and only give you this data. Okay, so first we have to clip the data. So clip raster by mask again, and the ODDEM. Okay, Dibrugarh. Then target the WGC 84. Okay, just save it as let us save it as like Dibrugarh. Okay, Dibrugarh DEM. Yeah. Okay, so now we have our DEM data. Okay, but this DEM data actually, when there are some in the DEM datas, there are basically some voids are there. Okay, like if let's say this pixel is basically if the water falls here, and the water is going like this this way. Okay, if there is a fill, so the water is actually get deposited in that fill itself. Okay, so for that reason we have basically finding some incorrect data. Okay, so first we need to fill that data. Okay, so just type the fill. Okay, fill, and in the fill you have basically this saga tool is used for all our hydrological calculations. Okay, so all our hydrological calculation is calculated using this saga tool. Okay, so if your this saga tool is not in your system, you can download for direct from this manage plugins, or you can download like search for saga for QGIS and you can download that. Okay, but basically this grass and saga is basically inbuilt information here. Okay, next, just click here, fill sync this Wang and Liu. Okay, So basically these scientists are basically given this algorithm to fill sync. Okay. Okay, we just select the data, and for now we don't need this flow direction and watershed basin. We only need this fill dam. Okay, so let's save it as fill. Okay,
Sir, can you
give
explain
our,
it again why we are doing this?
yeah, let me draw in. Okay, yeah. So actually what is happening that if the water is like this is the higher elevation, this is the lower elevation. Okay, so water obviously need to like move from this word and deposited here. Okay, later this is the outlet point and this is the basin. Okay, so but actually in the dam itself there are some small pockets, basically some errors are there. Okay, so this field sync what it does that this basically delete this extra layer, these extra pockets, and this allows the water to flow. Okay, like this one. Okay, so basically what is there is basically adjusted some holes in the dam data itself. Okay,
Okay, okay.
okay. Now just you have to save. Okay, we already fill Dibrugarh and run it. Okay, see, here you have from 73, actually it is from 487. Okay, just uncheck that extra errors. Okay, okay, so basically this is in point data. Okay, so here you have 1 second please. 9.407. Yeah, okay. Okay, so we have this field data. Okay, basically this is our Dibrugarh dam, and this is the field data. Okay, but before that, actually, when you calculating this all the dam data itself, okay, so this is all are calculated using that degree and meters. Okay, so we need to reproject all the layers. Okay, just reproject this Dibrugarh dam, and then we can start our all the processes. Okay, I just forgot to reproject. So you need to reproject to a UTM projection. Okay, so that all your layers, all your dam outputs are in meters and okay, and slopes are in degrees. Yeah, okay, not that. Okay, so we have source 84 and we need to uh, do it for, this is for 46 knot na. So WGS 84 46 north. Okay, so yes, Dibrugarh is falling here, and just save it as reproject. Yeah, see, this is slightly tilted. Yeah, if you see this one and this one, this is slightly, basically the image is slightly tilted. Why? Because we basically your file is basically like in WGS 84 ETM projection, but your this QGS profile is basically in QGS WGS 84. So you need to your canvas, you need to change your position for your canvas also. Okay, so the position of canvas is written here. So you can just, you have to just check here for this 46 north. Okay, okay, now you can see your, this is squared. Okay, now your area is basically your canvas is also in so you can see here also in the lower portion, when in the coordinates you can now find x and y values, not in degree decimals. Okay, so now you have the ATM projection. So so now let's go to again the fill, and now we have to fill the data, and yeah, okay. Okay, now we have the Dibrugarh projected data. Okay, let us now try the transparency. Yeah, okay. So before that you have okay, before that you have only up to 491. Okay, DEM data, but it is being corrected and now it is up to 496. Okay, so there is a elevation, uplifted elevation here also. Okay, then we need to calculate the slope, because in the formula actually I let me show you in the calculation itself. See, this is the LS factor calculation, and here you need to have the slope length, and slope length is basically divided by this 22.3, and this M is your the that is these factors. Okay, also there are other equation also. Okay, some, okay, so you have various equations, so you need to specify which equation you are using. Okay, see this one also, this is the flow accumulation and the cell size divided by 22 by m. Okay, okay, so again another one is the, okay, there is also a simpler one also. let, just let me know, this is the same one. Okay, see. Okay, that one also the same one also. Okay, here the flow accumulation and the cell size. Okay, okay. So we need this flow accumulation first. Okay, so flow accumulation, and we need this S is basically this slopeness, your slope gradient. Okay, the slope gradient, basically this is slope gradient and this is your flow accumulation. And cell size, we already know the cell size is basically our 30 meter. Okay, so to calculate the flow accumulation, you need to go to search for flow accumulation. Okay, so here you can find uh, now. Okay, 1 minute. Let's go to here. Then TN channels. Okay, okay. So flow accumulation, here they have flow. Okay, sorry. This is the okay. So in the flow accumulation, you have to give that field data. Okay, and then you have to give that. See here you have uh, okay. I think there is another tool in the Saga itself. There is the flow accumulation, and no, anyone already used the flow accumulation in QGS? Yeah, everyone tried that ArcGIS itself. Hello, hello.
I've used ArcGIS for this, but in this case, I think
Sir, can
uh,
you
the-
search for our watershed tool? Maybe.
Yeah, actually I know this is. I think in the newer version, they are deleted that.
And one more is there, Saga flow accumulation top down. Actually, I'm searching it, so I don't know, but I'm just
Yeah, that
searching.
one. That one also. I'm searching for that one. That one also. Flow accumulation, top and down, top down.
Top down, right, right.
But here I'm not finding that one. See, in my here there is no top down. So can you share your screen so I can guide you how to create that flow accumulation raster?
Actually, sir, in mine also I'm not getting it. That top down.
Okay, that one also. There is a tool. There. Uh, Yeah, this flow accumulation top down. You need this tool itself. Okay, this is in terrain analysis hydrology. Okay, so let's go to Saga hydrology terrain analysis hydrology. Okay, field sinks. Okay, the full flow accumulation is gone from here. Okay, yeah. Let us directly calculate this one, this LS factor. Okay, uh, because there is a tool known as this flow accumulation and top down. Okay, there is only you have to create that flow accumulation. Okay, but I'm not finding here, but I will let you know that where why it is not showing here. Okay, also to calculate the slope, you just need to this slope, and the terrain analysis you have slope. Okay, so you can directly click here the slope and okay, now we have slope in basically, say this is basically in degrees. Okay, now we have slope and you can see that this is basically higher slope region and these all are basically lower slope. Obviously these are basically the Brahmaputra is flowing here, so that's why this is only your uh, lesser slope here. Okay, this is a hill area. Okay, and if you see, if I open that okay, so here you can find a basically this is a hilly area. Okay, so that's why you can find this is basically your slope here. Okay, so these are basically plain areas. These are all are agricultural land and river bodies. That's why. Okay, so let us directly calculate that LS. So but directly calculation LS is not recommended. You have to calculate through that calculation itself. But I'm not finding that tool. That's why I'm using this LS factor. Okay, so you can choose that LS, and you have to create a catchment area, and then just you have to choose the cell size. So because here you can find the cell size formula. Okay, click here the cell size formula and your method anything you want. The more at all, see like here they are used, not this one. They are basically so Moore and Birch. Okay, 1986. So you can choose that one. Okay, this Moore et al. Okay, 1991. And also you can choose this also. Basically the equations are basically slightly different. Okay, then we need to just if your area is morely basically urban area, so you can choose that stable, or you can if your basically means barren land is more there. Okay, so you can choose the unstable dwelling area. Okay, then you can just have to run and you can find the LS factor. Okay, but this is not recommended. You have to first clear this slope map, and we have to create the flow accumulation image. But I will let you know, yeah, tomorrow that how to calculate this one. Okay, so
Sir, if we are uh, calculating with that formula, then what is
hmm,
the value of m we will be keeping?
m is basically you can keep for 0.4. Okay, 0.4 is the basically the average one. Okay, see, you can
Okay,
choose that 0.4.
okay, okay.
Basically here they choose 0.4. Here they he basically conditional variability that if the value is 0. Sorry, 1%. If the slope factor is 1%, then you have to give the 0.2. If it is between 5%, then you have to give 0.4, like that, this one. But you can only give that 0.4 itself. Okay. Okay, so for now, so this is basically a failed mission. I do not know how, where the tool is basically gone. Okay, so for now, let us calculate that p factor. Let us do a LULC map. Okay, let us prepare a LULC map. Yeah, so we have this one. We already created our C factor and NDVI yesterday. Yeah, this is C factor and NDVI. Okay, we created this one. Okay, let us okay, let us remove the layer. Okay, let us import the image again. I'll put in P factor. Yeah, so this is our data. Okay, just create true. Let it create true color composite. Or true color composite basically 4, 3, and 2. Okay, now we can direct we can easily see. Okay, let us delete this one. Yeah. Okay, so let us discuss about p value. Okay, so basically there are basically different. We have to calculate different LLC classes. Okay, you can calculate anything. Okay, and basically the LLC classes are basically assigned some p values based on their management practice. Okay, so if let's say if there is some bound is there, or some that what is called that bounding. Okay, farmers are bounded their fields. So if that is bounded, so that means that is less likely to erode. Or if say there is urban area, so urban area is concrete and buildings are there, so obviously there is no erosion going to happen. Okay, also if there is a forest, yes, and then very low erosion can happen. Okay, so like that there are various p value assigned to them. We just need to assign this value. So to assign this value, first we need to generate LULC map. Okay, so to generate LULC map, obviously we need to download some data set like Landsat and Sentinel. Okay, and we can process it using some methods. Okay, also there are available dataset already pre-downloaded. You can download directly the LLC data. Okay, like you can find the 10-meter resolution. Okay, from this Sentinel. Okay, so let us download this Sentinel 10-meter resolution, so that we can compare our data set to the this wall cover data. Okay, so let us search for this Sentinel land cover. Okay, yeah, see, they have calculated from 2017 2017 to 2024. They have calculated for whole world using only Sentinel-2 image. Okay, very well generated. Okay, but this is available up to 2024. We need the data set for 2025, so that's why we need to process again. Okay, so basically this is Dibrugarh. This is Dibrugarh, and you can find that this is the our Brahmaputra river. These are basically barren lands. Okay, see the barren lands. Okay, and these are basically agricultural lands, and these are vegetation cover. Okay, and see this is the our that one the portion where there are various mountains are there. So this one is the mountains. Okay, so you can see how this is going to change from 2019 to 2024. You can have the that animation. Okay, so you'll see later. Okay, see, now we can, if you want to download this 2024 data. Okay, so just click the download TIFF, and download TIFF you can download for 2024. Okay, let us save it in P factor. Okay, so data set is about 39.8 GB data, because this is for, but if you only need to download for your area, so just you have to select, let's say Dibrugarh in this tile. So just select this tile, and then you can download this 2024 data. P factor, yeah. See, now we have only 200 MB data. Okay, so choose that, click on that download data, and then click the tile you need to download. Then you can download for any area you want. Okay, let it download, and let us do our process to create our own LLC map. Okay, so basically to uh, create our LLC map, you need to you need to install some plugins. Okay, so the plugins is basically known as semi automatic classification plugin. Okay, or SCP. Just search for semi, and you can find that there is semi automatic classification plugin. Okay, so in the semi automatic classification plugin, please go to the install plugin. Okay, see, now I have been asking for some issue. No module name, remote your sensors. Okay, so for that, basically you need to go to this SCP plugin. Okay, SCP plugin. Okay, so okay, let's just take. Yeah, for the issue, you just have to basically install that remote your sensors. Okay, just open your this OS panel. Basically the QGIS has its own this cell tab, okay, where you can directly modify the files in QGIS. So we just need to download this one. Okay, so just click this code and enter. My system is being slow. For many systems actually this error is appearing. Okay, so you need to install this one. Yeah. Okay, see the successfully installed. Okay, so now we can open our SCP plugin. Yeah, okay, we need to open it once again. Okay, so today I have internet issue also my system is very lagging today. Yeah, QGIS is opened. Let me do that process once again. So go to this OSGeo4 cell and you just need to download the motor sensors. Yes, everything is okay.
Sir, I guess the issue is you have created your
version.
user profile. No, sir, user profile, soil erosion, right? If you do it in default, so I think that will work because mine also having some issue when I changed it to means created for new profile. But I successfully downloaded that saga and mine this as semi-automated is also working and saga flow accumulation is also showing now that top and down.
Okay, so problem is the in that profile section, no?
Yeah, I guess problem is in that.
Okay, so let us then I'll try it in QGIS 4.0.
Sure, sir.
Yeah, let us open my QGIS 4.0. Okay, yeah, let us check what is that flow accumulation, no?
Sir, you have to first install the plugin Saga Next Gen.
Okay, so then but for now let us do that semi-automatic. um, why is so slow today? Yesterday we were working so fastly, huh? This is being very slow. Yeah, this is stalled finally, but scikit-learn and pytorch is not there. Okay, so you need them. Okay, so now we have our this SCP plugin. Okay, okay, see here we have, yeah, this is the SCP plugin. Okay, for 4.0 this is actually uh, very new. Okay, also here actually what is very good in that you can directly download the Lancer and Sentinel data from here itself. Okay, the harmonized Lancer and Sentinel you can download also, and here you can download directly from the from this. Okay, but we have our data, so let us import our data. That is the Dibrugarh Landsat file. Okay, so we have our data set. Okay, so we have to wait. So in the default profile, your this all are worked. Huh? So let
Yes,
us change
sir.
the profile. So change to default.
Maybe, sir, this issue is due to 3.10 version. Mine is 3.40. So in that default is working, but profile having some glitch. So
Yeah.
you can but
No,
try.
here see here you we have already our assumed
Exactly,
plugin.
sir. Exactly.
Yeah, so it is working here. Okay, let me just check that one. Yeah. So here also I am finding that same error.
Okay, then that it will be version error
Version
then.
is, yeah.
Yeah.
But in the QGIS 4 it is lagging, and QGIS 3.1 is not working. The day before yesterday also we have some error. That's why. So I think we need to extend our webinar from 5 days to 6 days. So there, this is our segment P factor. Okay, so we need to import our data. Yeah. So here we need to give it to us 432. Okay, so now we have our uh, data. Okay, so now we need to basically see if you are go to this I mean, open file, and from the open file we need to click this Dibrugarh Landsat. Okay, so now let me put it here. Yeah, okay, now we can work. See, Now we have our 11 bands here. Okay, see here we have our 11 bands. Okay, so if you want to do it for only for your 7 bands, you can work on that. You can also use all the 11 bands itself. Okay, so basically all the 7 bands have 30-meter resolution, and all other bands have that 100-meter resolution. Okay, so for that only they are not this they you can find somewhere in everywhere they are using only 7 bands. Okay, but we are adding 11 bands, and here you can also composite your ndvi dam data, so it can generate more accurate data. Okay, so here we have this, see, you have to check the wavelength. Okay, so for wavelength we have the landsat 8 9 from 1 to 11 band. So if you are choosing only let's say oli band for 1 to 7, so you have to choose this 1 to 7. So for now we have to choosing this 8 to 9. Okay, 8 9 1 to 11 band. So because we have all the 11 bands here. Okay, so now uh okay, let's select all. Wait a minute, it is loading. Okay, 1 minute please. So actually this is SCP 9 version, so they change okay, here you can change directly the 432 and all. Okay, yeah, so here see, if you are choosing this 432, or let's say you can choose that 732. Okay, so 732 is basically the false color composite. Okay, so just you can change anything you want. This is the natural color composite, this is the true color composite. Okay, so we are basically and this is actually directly a virtual raster is being created. Okay, so this is a virtual raster, this is our raster file, but it is created a virtual raster because it is .vrt extension, and that extension basically working in this. Okay, so first we need to created this virtual band. Okay, so no need to save this one, as this is a virtual band, this is only a temporary file. Okay, now we need some training samples. Okay, so for the training sample, basically your this profile is basically to handle the training bands. Okay, okay, see, so how this is going to work. Okay, so let me finish the slide first. So we have, first we have our supervised classification. So in the supervised classification we have to create we have to train the model first. Okay, by creating the shape file by ourselves. Okay, basically we are creating some that it is water, it is vegetation, and then that is learned by computer, and it can create the LLC map. So you can use the maximum likelihood, or you can use some machine learning framework like random forest or SVM. Okay, also you can create LLC by unsupervised classification. So basically in the unsupervised classification, the computer itself create using some its algorithm and create some classes. So you need to verify that classes and need to confirm. Okay. Also you can you choose the random forest, XGBoost, okay, deep learning, you can anything you want. Whenever I created the LULC files, okay, I created LULC file for state level itself. So this random forest is basically working with highest accuracy. Okay, I created using unet, CNN, and this random forest, XGBoost, SBM, all I tried, but this random forest is basically working with the highest accuracy. Okay, but for now we are basically either we use this maximum likelihood or this random forest. Okay, so before that we need to just create some samples. Okay, let us create some samples. For that you need to create this new file. Click on the new file and save it as, let's say, training samples. Okay, save it as training samples. Okay, so here you have sending samples, you have sending samples. So now we need to basically create our polygon. Okay, this is the polygon. So how many classes we need to classify? Okay, let's see some papers. So for this reason, they are classified like 8 classes. Okay, water body, snow, forest cover. Okay, for their area they have snow. For the reason they have created the snow band also. Like here, you can find that he created only 5 classes. Okay, our area actually these for their area they have forest lands. Okay, but for our area basically we have more like agriculture lands. Okay, let me show you. Just go to SCMJS and the base map, select the Google satellite base map. Okay, okay, so see, this is the Google satellite map and we can see there are see these are all are basically agriculture lands, but there are basically, if you see, these are see, these are small ponds also. Okay, so there so this one, see, this one is also a agriculture land, and you can see there is some crops here. And in this agriculture land basically this is called as fallow land. This is a agriculture land, but for this time this is not sowing. Okay, there is no crop here. Okay, so you can find everywhere like this one. Okay, fallow land and agriculture land. Okay, this is agriculture land. Okay, so our area is basically agriculture land dominated. If your area is forest dominated, you can choose some forest file like this one. They calculate forest and then grassland. Okay, let me just show you other. See here also, forest, cropland, settlement, water, wasteland, like this one. Okay, yeah, water body, marshland. Okay, so let me show you first how to classify basically. So just search for your LULC data by this NRSC, LULC guideline basically, LULC guidelines by NRSC. If you see this document, okay, so basically ISRO or ISRO is basically classify as this. Let's see, you can classify as built up agriculture forest, or you can in that built up also you can classify as urban, rural, mining. Okay, for agricultural you can have cropland, fallow land. Okay, all these things. Forest, these have all the classes for you can classify as forest. Okay, so let us calculate for our area. Let us calculate, one is the built up, obviously there are some built ups there. So you have to classify built up, then classify some water bodies. Okay, so rivers, water bodies basically. Then agriculture, in the agriculture, let classify as cropland, fallow land, and let's classify another one as forest and barren land. Okay, so we have basically one, two, three, four, five classes. Okay, we need to classify five classes. Okay, so okay, so when you are classifying LULC, please make sure that your base map is on, but never take your samples from base map itself. Okay, because base map is of another date and another year itself, and your date is different. Okay, see, you can see the difference here. See the in the Google Satellite Hybrid, you can have this sandbar. Okay, and here you can find that there is water here, less sandbar. Okay, so always please try to uh, 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 means take reference from the base map, but do not take samples from the base map. Okay, take sample from your raster image. And also how much samples you need to classify with good accuracy. So basically there is no direct relationship that if this much of if you collect more number of samples, so you have more accuracy. No, you have to take lesser number. Okay, but you have to take with that means more quality. Okay, quality samples you need to take. Okay, you need to take you need to classify with quality samples. Okay, so but 100 pixel for one class is great actually. Okay, if you have smaller area like this one, you can have 50 to 60 or like that. Or if you have larger area, let's say for Assam or state level, you have to choose more than 100 pixels. So to create sample for 100 pixel, so you need I think 8 to 10 samples for each class is sufficient. Okay, this is our smaller area, so you can have 5 to 6 samples for each class. Okay, so let us first means create our for, let's say, water sample. Okay, so water. Okay, and go to this polygon. Okay, zoom into that and create a polygon. Okay, and to complete the polygon you need to just right click. See, this is a polygon. So we need let's say 7 samples, but with in a different area. Okay, your samples must not concentrate in one area itself. Okay, you need to basically in every corner your samples must be there. And make sure when you are making the ROI, make sure that the you need to click the control bar control key, and then just click. And okay, if you did not click the control button, so this is going to delete. Okay, and please create some clean profile. Okay, if you have any doubt that this area is water or not, or built up or not, please do not means take that sample. Okay, let's go to other area. We have taken 2 samples from this river. Let's do it for, yeah, let's taken from this river, or let's take from this river. So yeah, one class. Sorry, I forgot to click. I forgot to press control bar. Okay, I during various time I am having this issue. I forgot to. Okay, we have 3 samples. Let's take more samples. Okay, from variety of areas, basically you have to click. If you finding some let's say ponds or canals, so you can have that you can choose that sample also. Okay, just click on this, right click. So we have four samples or five samples. Let take another one from this corner. Okay, let's have an example from this one. Yeah, we have six sample for our water body. Okay, after completing, click on this save button. Okay, save.
Sir, so we have to press and hold the control button while taking the classes.
Yes, yes, otherwise it get deleted. Okay, so we have our water sample. Okay, next we have to classify the as class 2, and class 2 let take forest. So click on forest and let us. So this area is basically forest land. Okay, and I don't think okay, so you have no forest land anywhere else. Okay, these are actually small trees are basically, but forest is forest only. We are finding forest only here. Okay, so these are basically the cloud masks. So that's why this uh, type of you can find. So okay, so one. Okay, we have taken larger polygons. Okay, so I think it is sufficient because it is very lesser in number. So let's check another one. Okay, so I think four is enough. Yeah, we have our forest class. Then go to let's take the agriculture land, but we need cropland. Okay, so for cropland, so these are basically croplands we already see in the Landsat image itself. So just click one polygon here. Let's take a sample from here. Okay. Oh, I forgot again. Yeah, how many samples we have now? One, two, three, and here four. Okay, our samples is basically concentrated in the down area itself. Let us take some samples here also. Yeah, and some here also we have some agricultural lands. Yeah, okay. Let us save it. Okay, you have to take at least minimum at least 6 to 7 polygon. Okay, for each class so that it classify better. Okay, so cropland is there. Then let go for fallow land. So fallow land means the agricultural land, but it is not sowed yet. Okay, open profiles means that is not a barren land nor a cropland. Okay, so that's why this is not an this fallow land. I've taken 3 samples. 4, 5, 6. Okay, enough. Then our last class. Okay, we have 2 more classes. Okay, 2 more classes. Let's take for we already did for forest. So let's go for urban. Okay, urban. Okay, class 5 is our urban land. So you can find the urban land here. So in the urban land itself also there are some like roads and urban area, rural area. So this is the urban profile because this is so straight. So just example here. Oh, sorry, I forgot to again. Yeah, so taken 2 samples here. Let's take from here. See, this is the built-up area. We already see that. We're seeing so this is so yeah. Let's take another sample from here itself because this is a highly built-up area. Okay, we have taken 4 samples. Let's take another sample like from other areas. If we can find any built-up area here, I'm not sure here. Okay, this is the road network. Okay, but for first try, it is very difficult to find accurate result. You have to then again modify your let's say I s- yeah, we have 5 classes, 5 points, data points. Yes, this one is also a very good. Okay, so we have polygon for urban lands. Yeah, okay. Then last one is your barren land. Okay, that means there is a barren land. Basically, you can select barren land from like for this area is basically agriculture dominant, so you cannot find barren land much here. But you can for barren land you have to choose from, let's say there's some, if some mountains are barren mountains, so you can find it there also. And also this basically this sandbars are basically the barren land itself because this is only sand. So for barren land you can choose the sandbars as barren lands. Okay, let us choose from here also. Okay, these are also barren lands. Okay, we can have also another class for vegetation, so you can find this vegetation here. Okay, so these are barren lands. Let's take another sample from one sandbar. Okay, So we have samples. Let's see how our class is, and then we can change. Okay, so when you are taking samples, okay, if you are finding difficulty to find, let's say, vegetation areas, so you can choose the false color composite itself. Okay, so here you can choose the false color composite, and you can have a different point of view for to choose your data. Okay, see, the water bodies are different, the vegetation are more red in color. Okay, so you can have good samples. Okay, so now we have already created all this. Okay, so to classify, okay, just we need to go to that SCP. In that, this is band processing. Okay, if you choose the classification, also here we have also classification also there. Okay, also you can find information here also, classification, and here you can find that there is maximum likelihood, minimum distance. Okay, then random forest, SBM, all the things. So here also you can choose like maximum likelihood. Okay, let us choose maximum likelihood and click the run. Let us save as LULC. It will take some time, 2 to 3 minutes to minimum. So did you get the process to calculate LULC? Anyone have any doubt? I think it is some error. Yeah, okay. Okay, so this is the for water. So let's change the water color to, let's say, blue. Okay, and for fallow land, let do it for, let's say, pink in color. Okay, not yellow, yellow or orange. Okay, and for this barren land, let's take white. Okay, and for urban, let's take means red color. And what is that, cropland, up to cropland, and the darker green. And the fallow land, let's take it as yellow. Okay, so okay, so now we have oh sorry, yeah, so now we have see the classes, but this is not correctly generated. So where the issue, let's say, let's see. Okay, so basically we have the vegetation class is actually generated well. Only we have forest here, but then these are basically some errors are actually happening here also. Okay, so what is about fallow land? Yeah, fallow land is actually generated well, because if you see that raster, see the okay, let me change to 432. Okay, so we have the fallow lands. The fallow lands is actually appearing very well. Okay, see, you can see the fallow lands here. Okay, so only error because of this, I think the this data for cloudy data. Okay, I think the error. See this one. See, these are all well generated. See how much is this one. See this one. How much well it is generated the fallow land. Okay, let's see. Let's do it for cropland. See, these are the croplands, and see the cropland also appearing very smoothly. Okay, these are all croplands. Yes, the cropland also appear very smoothly. Then go to the urban lands. So I think we have accuracy around. Okay, see, let's see the urban lands. Okay, see, you can see the urban lands, but urban lands are actually the these roads and all also are basically in urban lands. So basically, urban pixels are basically it is showing very error. Okay, okay. See, this cloudy pixel is the cloudy pixel is classified as the urban. Okay, so we have to re means redo our urban files. Okay, what are other things? Okay, so let's see. Yeah, the water files are generated correctly. See, the water files are correctly generated, but only issue is that the barren land. I don't know why the barren land is actually appearing in all our areas. Okay, so I think this is because of this cloud itself. Okay, so also we have to take some water samples from here also, so that this canal also being generated well. Okay, but this road networks are actually this is, I think this is almost correct. And see this area, we collected this area as our urban land, but actually this area is covered slightly in clouds. Okay, so that's why we're facing this much of error. But I think if we choose some let's say no cloud data, or we can download sentinel-2 data, so we can have more accurate result. Because 2025 you can find the sentinel-2 data itself, and sentinel-2 data the cloud pixel actually very less, that also also well generated, but these pixels are basically the errors. Okay, so because of basically the areas we have more fallow land, cropland, forest, really highly accurate. Only have to recheck that barren land, because we are selecting these areas as barren land, and these are basically whitey pixels. So that's why the all areas are selected as barren lands. Okay, but you got the point how to basically create the this one. Uh, okay. See, this is the classes by this sentinel-2 data. Okay, and the sentinel-2 data, actually sentinel data, you can find this as your let me show you. This is a sentinel data that we are calculated. Okay, so it has see 1 to 11 classes, and you can find that information in the here itself. Okay, okay, so here you have water as blue color, and these trees are green color, and this bare ground and rangeland are yellow color. Okay, so here also in our area, also this orange color is basically your uh, rangelands. Okay, rangeland and crops. So this rangeland and these are see these are basically forest lands. And see canals level also, this canal data also, because this is 10 meter per pixel resolution, that's why it is classifying the canal also. Okay. Okay. So what we can do here, we can actually reclassify to, let's say this is of 12 band data, 12 data set are there. So we can merge the this 12 to one sorry, six classes. Okay, let's say we did not need the let's say we did not need the snow ice. Okay, so snow ice is already gone. And so we can now we can now create six file, okay, from this 12 file. Okay, and the last thing we need to do that, one minute please. Okay, so this is our class. Okay, so we have completed the scp data. Okay, so we need to define this. Okay, then we can find our correct data sets. So let's do it to here also. Okay, here you have to go to raster to vector, raster to polygon. Okay, raster pixel to polygon. So this is you have to get LULC, then this is all are correct only. Now we just need to let's see, for water we need to give the water class to. Okay, let me open that table here. Okay, so water, we have to give the water. Okay, see the p factor value. So we have to give the water to 0, settlement to 0, cropland to 0.4, and forest to 1. Okay, so these are the value we need to assign to the classes. Okay. Okay, this is not. Okay, so we need to go to the reclassify by the table, and here we need to give to our this, where is that, LLC. Okay. Okay, so we have water body. So for water body, let's give the value as 0. Okay, then for forest, give value 1. Okay, one. Yes. Okay, then for cropland, cropland, let's give 2. Okay, like that you have to give the all the things. Fallow land 2. Oh, sorry, why I'm giving 2 here. Cropland is 0.4, no? 0.4. 0.4. And the fallow land is this is subland 0.3 to 0.5. Cropland, okay, to the forest and shrubland. Okay, just keep some value here. So let's say for fallow land it is more prone, so let's give it as 0.3. Okay, then this is for urban I think 1. Urban settlement is 0. Okay, so give settlement as 0. Then as barren land is obviously high, so for barren land give your let's say 0.8, or wasteland is 0.7. Okay, so 0.7. So we have to just assign the values to the to these classes. Okay. Okay, so after we did this one. Okay, so we when we give the data here, so okay, there's some issue. Okay, no worry. You have to just we have to just put some assign value. Okay, to the classes itself. Okay, so please try this LULC classification. If for your area you can find better results. Okay, or you can choose this one also, this file also. Just clip for your area, clip your area, and you can then assign your classes or numbers to the all the classes here. Okay, you have this 12 classes here, so just assign 12 classes the 12 values. Okay, then your p factor is ready. Okay, so in the next class we have to just create, we already created the slope file. We need to create the this flow accumulation. Okay, here it is not showing the flow accumulation, that's why we are not do today. Sorry, flow. Okay, this is not appearing.
Sir, Saga next gen plugin is there. In that, it
Yeah,
is there.
also I am using for QGIS 4 na? That's why it's not okay.
Saga next gen.
I have to download from there and
Okay,
need
okay.
to install here. It's not showing.
Right, sir.
Next gen, no, there is no data. Okay, so I need
Okay.
to, you can also try this one. Okay, but this is mollusk. Okay, and it is only applicable for older versions, like I think in QGIS 2 or I think QGIS 2 or something. So it is what is does that you just classify your land use land classification and give it to it. It can predict for, let's say, 2030, 2035. It can predict the land use classes. Okay, so we'll be seeing that this is the mollusk. This is basically to predict the land. cover classes. Okay. Okay. So the p factor only need to create. We need to create only the p factor. Then we will create that ls factor tomorrow, and just to multiply to create our uh, a factor. Okay, soil loss. And also I will share you the code, google Lessons code, so that you can directly run and create for your area. Okay, so anyone have any doubt?
Sir, the raster pixel to polygon which we have done